So we're going to go over testing a basic compressor. It's very similar to a dryer motor. The compressor has a starting device called a relay, which is this bottom piece here, the overload, and a capacitor. I'm not going to go into testing this now. I want to go into how you test the compressor and find out the common start and run, and how to use a 3-in-1 kit to test to see if the compressor runs. First thing you want to do is set your meter on ohms, and if you look, the 3 pins here, and it's very important to identify what pin is run, what pin is start, and what pin is common. So the first thing we want to do is we want to draw a picture very similar to the way you see it on the compressor with 3 dots, like so. And then what we're going to do is we're going to make tests from each pin, trying to find out the readings from each one. Now, if I'm going to do the bottom 2 pins here, my meter is not reading. Let me test it again. Okay, my bottom 2 pins are giving me about 13.1 ohms. So if I was touching these 2 pins from here to here, I have 13.1. So to make things easier, first thing I'm going to do is I'm just going to give them letters or numbers. I'm going to say this one's A, this one's B, and this one's C. So my first test from A to C equals 13.1 ohms. Okay, so that was testing these 2 pins on the compressor. The next 2 that I'm going to test is A to B. When I touch those pins, I'm going to get a reading of, give the meter a second, 8.9, 9.0. Let's just round it off to 9.0. So from these 2 pins here, A to B, I have 9.0 ohms. All right, and then the third one is going to be B to C. And we're going to test those from here to here, and we get a reading of 3.9 or 4.0. Let's just round it off to 4.0. So B to C equals 4.0. Now, one thing is there's only 2 windings out of the 3 pins in the compressor, so we're trying to find out which one's common, which one's start, and which one's run. One thing you know is a run winding is always the lowest reading. So if we looked at it, out of the 3 readings of 13.1, 9.0, 4.0, I know that my 4.0 is my lowest reading, which was from B to C, from here to here. But it doesn't tell me which one's the run, which one's the start, and which one's the common. So what we got to look at is, when you look at a typical motor, you got a run winding and a start winding. They both join at a single pin. So let's just say this was the 4.0, and this one here is the 9.0. So if I touched here to here, I got 4. Touch here to here, I get 9. If I touch these 2, there's no winding here. So if I touch these 2, it's going to read through this winding and this winding, and 9 and 4 added together gives me the 13.1. So the easiest thing to do when you have 3 readings is take your highest reading given, which is 13.1, and just cross it out. Just like that. So now you know your run and your start winding, where run is always going to be the lowest reading. So when we look at this, what you want to do is you say, well, I got a reading A to B and B to C. And through those 2 tests, what 2 tests do they have the same point in common? And that would be letter B. So letter B is my common terminal. So I know that A to B and C to B are my windings, and B being the common, I'm going to draw these windings like so. And because both of them use B, this is our common terminal. Now if I look, I said my lowest reading is my run winding, so C to B is 4.0. I've already identified this as common. This one here is my run. And then my final one, A, is going to be my start. Now, we call the pin the start pin but our start winding is between these 2 points A to B. My run winding is between C and B, but this one is my run terminal. Now that's important because what we have here, make sure you zoom in on this. What we have here is something called a universal 3-in-1. Sometimes they call it a hard start kit. And I have one open out of the package here. This is what it looks like here. Basically, this tube here is the same thing that we have on the compressor. It has a capacitor, it has a relay, and an overload built in it. Now, it's very important when you replace these that you look at the numbers on here. URCO 410. Okay, RCO is relay, capacitor, and overload. That's what the RCO is. U just means it's universal for most brands. But the most important part is the horsepower rating, 1/4 to 1/3 horsepower. They have others for bigger compressors. And because this relay inside here is called PTC, it needs the current from the compressor to take the start winding out of the circuit. And if we don't get the right horsepower rating for our compressor, we put the wrong one in, there's a possibility we can burn the compressor out. So what I did with this 3-in-1 kit is we have 2 terminals here, which are the 2 black terminals. This is line 1 and neutral coming in. It's not that important which one's line 1 and which one's neutral, but we hook up that in. These 3 are going to the compressor. On the 3-in-1 kit, I don't know if you can zoom in on that, we actually have a drawing here saying that the red winding goes to run, the white is start, and black is common. I always remember that red run, white like the starting line of a race is the white line, and black is common. What do all the compressors look like? They're all just black bowling balls, so black is common. So once you identified your start, your run, and your common in your drawing, then you just attach these to the right position. So red being run, the bottom right terminal is my run winding. Black being my common, which is the top terminal. And then white being start. Now you could wire this up on a compressor, just be careful that none of them touch each other. And then I'm going to go ahead and plug it in my test cord here. Let me get this out of the way. Plug this into the test cord, and my compressor is going to run. So if you have a bad compressor in a refrigerator, or the compressor is not running, and you don't know if it's the relay or overload or the compressor itself, if you have a 3-in-1 kit hooked up to a test cord like this, you can connect this directly to a compressor and see if it's pumping Freon by just plugging it directly in. And as you can see here, the compressor is running. I can see that these 2 are my suction here, and I can see my discharge is flowing. So if I remove a compressor from a refrigerator and I thought that the compressor wasn't pumping, you could run it like this. I don't recommend normally running it and put it back in the refrigerator because these are 134A compressors, and that oil is an ester-based oil, which is a very hygroscopic oil, and it absorbs a lot of moisture, so it's not really good to run it too long. If you turn it on just for a second or so, just for testing purposes to see if the compressor is good or bad, this is the way to do it. If you have a bad relay or overload, your compressor is not going to run. And some people misdiagnose the refrigerators. They have a bad compressor because the relay's bad. They don't really know how to test it out. Having a 3-in-1 kit is a good way to get the customer's compressor running so you can order the right relay and overload and replace it later. Some people leave them on. Sometimes they work good. I've noticed in the past, though, that sometimes I've replaced a compressor with a 3-in-1 kit and then come back a couple months later and find out that their compressor is no longer working and it might have burned the compressor out. So I like to use it temporarily for the customer so she has a refrigerator working and then come back with the right relay and overload. But instead of leaving that attached to a test cord like you have here, this thing is, these 2 wires are attached to the power supply that would come into the back of the relay here, and the compressor would cycle on and off just like the compressor would if it was using the original factory relay and overload. So this is just a quick way of checking the compressor. Again, take 3 readings, eliminate your highest reading, your lowest is your run, the next one is your start, and if you just look at what pin that they both use, that's your common. And that's the way you test a compressor. Someone wrote me their readings were something K ohms, which is a little bit too high. These compressors run anywhere between 1 and about 10 ohms on average. And that's it. That's how you test a compressor.